Hey everybody, here today just to give you a quick overview of my lazy backtesting tool. I wanted to test out some lazy data structures in JavaScript, and also I wanted to stop messing around with Excel. So here's my stab at doing backtesting. Let me give you a quick overview, run through. So first of all, just want to add data to your backtest. So your universe of data comes from Quandl. I have two examples set up here. Just click on add, and we see that the data is requested and then retrieved. Oh, actually, before I go any further, I need to put in the Quandl key, which I copied previously. So you can paste it in there. I don't save it. I don't do anything with it. So just so you don't get caught out by Quandl restricting your pulling data down. So we added the two data sets. So here it's the S&P 500 from all of Quandl's data from 1950, and then here's the skew index from 1990. So the system basically puts them both together. So it ignores anything before 1990. So that means that all our skews dates match with all of the dates that we have for S&P 500. So it's one of those small things that is kind of nice. And then you can code up your own specific strategy right in the browser. So it's just vanilla JavaScript. Here we have an if, then else. So here it is. If the latest change in the skew index is negative, less than 0, then we weight the S&P 500. So this is basically a trading rule. We weight the S&P 500 by minus the change in the skew index. So if it's less than 0, the skew is getting lower, which is generally a good sign. So that means minus minus is a plus, and then I multiply by an arbitrary 7, but you could change that to 2, for example. And then vice versa for shorts, right? So if it's greater than 0, if the skew is greater than 0, then the weight ends up being negative. So we have the data, we have the code, trading rule, and we hit backtest. And right in the browser, it doesn't go to a server or anything. Then we have the results here. So here you see that the Sharp is 0.5 or so, the skew is about 3. Sample size, so the number of months that we test for, 291, which is about 25 years. Right, so let's do something a little bit more interesting, and let's add some more data and code up a new strategy. So let's so we're taking the Google data source, and let's add in VNQ, the Vanguard ETF, and again Google data source, and we go with the EFA ETF, and then we go to GLD ETF, and we shall also take the Lehman or Barclays now Global Ag ETF. So we got all the prices pulled in for each of those ETFs. So here's all our data we have right now in the system. And so it's all available here. So let's change our rule. So what we're going to say is if the S&P 500, so also in the background basically I think it's 11 months of returns for each decision. So each decision is based on up to 11 months of returns. You can change that if you want. So previously we just used the first element in the array. Now we're using the whole array, so it's 11 months worth. And what we're going to say is use the JStat JavaScript statistical library. We're going to take the mean of the array. So we're basically saying in the last 11 or so months, if the return's been less than 0, then what do we do? So if it's been less than 0, we'll say the weight for the S&P 500 is 0, and then on the other hand, if it's greater than 0, we'll say the weight is 0.2. So data is the input, weights are the output, right? So now let's use another ETF. So we'll use the VNQ, Real Estate Vanguard ETF. Oh, it should be Amex. American Stock Exchange. So here we've added that as well. So real estate, and now next EFA. EFA, so it's the same rules for each asset class or ETF. You can obviously do a nice loop so you don't have to write so much, but right now I just want to make it look as straightforward as possible. So after EFA we have GLD, and then we have AGG. GLD, 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 and AGG, AGG again, AGG again, and if I haven't made any coding errors, hit backtest and see what we have. So usually it's a lot quicker. This is a 2008 laptop. It's pretty slow. But on my desktop, this is much, much quicker. Did we get something? Ah, we got something. So let's have a look here. Sharp 0.6, standard deviation, average return, skew slightly negative, sample size 113. So what's that, about 10 years or so? 10 years of data. So whatever the shortest history is, that's what we're limited by. Okay, so that's something to think about. So there you have it. We coded a new strategy, sort of a Meb-Faber-esque timing strategy, and we got the solutions.